It enables cars to drive across the land, planes to soar through the air, and boats to sail across the ocean. In 2011, the U.S. Energy Information Administration estimates the United States consumed about 134 billion gallons of gasoline. Now, with rising gas prices and a desire to lessen the impact of fossil fuel emissions, scientists are on the search for new, cheaper sources of energy, including fuel made from living material known as biofuel.
Biofuel is any form of a fuel that has a biological origin.
While current sources of biofuel already exist, such as ethanol made from corn, scientists like Steve Hutchison, a professor of microbiology at the University of Maryland, are seeking other options that would not take away from our food supply.
Corn has an image problem. The image problem is food versus fuel. So there's been this tremendous push to find alternatives that have a smaller impact on food.
With funding from the National Science Foundation, Hutchison has found a new approach to producing biofuels from cellulosic biomass, the fibers that make up the structure of plants such as wood, grass, or even leftover agricultural products like corn stalks. Part of what makes Hutchison's discovery innovative is its ability to imagine a new and positive use for something that was having a negative and potentially damaging impact on the environment: a marine bacterium called Saccharophagous degradans.
This is a bacterium that was originally identified in decaying marsh grass in the Chesapeake Bay. It came from a section of Virginia and was causing major damage in the ecological preserve.
In the late 1980s, researchers identified the bacterium, or bug, as the cause of a major die-off of salt marsh grass in the Chesapeake Bay, the largest estuary in the United States.
It's an interesting little system because the bug itself grows in the ocean, and that's huge. And therefore, the scientific term would be that's an infinitely large dilutant. And yet, the bug itself can sense when it's in contact with something it can eat.
After listening to a lecture about the bug, Hutchison became fascinated with the organism and decided to investigate it further to see if it could in fact degrade cellulosic biomass. Hutchison sequenced the genome of the bug and discovered that it has the ability to release more than 100 enzymes to break down the three large molecules that make up the cell walls of plants: lignin, hemicellulose, and cellulose. The bug then eats the resulting sugars for energy.
You got to break down the lignin, you have to break down the hemicellulose, and you have to break down the cellulose. And those aren't easy things to do.
Hutchison realized that the bug's unique set of enzymes could be reproduced and used to convert cellulosic biomass into sugar. It was then possible to ferment these sugars to produce the biofuel ethanol, but instead of making the fuel from corn, it can be made from any plant material.
It's really when we had the genome sequence and could go through the annotation, which is what the probable functions of the genes are, that we could come through and say that this is an amazing bacterium.
With a new, efficient way to process cellulosic biomass, Hutchison filed several patent applications with the U.S. Patent and Trademark Office to protect his ideas. He also started his own company in 2006 and filed a trademark for its name, Symetis, to brand his business and identify the products it produced.
We started out with producing enzymes, realized that the market wasn't as strong as we thought, and moved over into a different area, which was how to engineer the bacterium to make value-added products. These are going to be chemical products that have a higher value than either the feedstock that is being converted, the biomass, or the biofuel that's being utilized.
Today, the company is called Ametis, and its research and development arm operates on the campus of the University of Maryland. While cellulosic biofuels are currently in the pilot stage, Hutchison says they are the next phase of growth for the biofuel industry that could produce a cheaper alternative to gasoline. At the same time, his research is an example of how sometimes innovations can pop up in unusual places.
That you can come through and take something that you've been studying for a long period of time, continue to study, but yet realize that the applications of this are huge and could be life-changing in terms of what we use to make our energy.
An innovative, alternative form of producing biofuel inspired by a tiny bug that one day could have a huge impact at the pump.